Hello and welcome to part 4 rather, of my chemistry tutorial. In this part we're going to talk about the properties, you can write this out, properties of matter. And as you can see above me we have the periodic table, but again we're going to shrink it off and move on to properties of matter. Now, matter will always have two types of properties. So let's say we have matter. It'll have two types of properties. It'll have physical and it'll have chemical. And I'm gonna do all the physical in that color and all the chemical in that color. Now, physical properties of matter are qualities that can be observed without changing, this is very important, without changing composition. So what that means is we don't have to burn, destroy, radically annihilate in a flame of raging fire composition. We don't have to do any of that in order to observe them. Whereas in chemical properties are properties that only can be attained by changing the composition. And by that I do mean annihilate, kill by fire, and all that good stuff. So we have changing composition. All right. So we have a pretty broad spectrum right here, and I'll give you fine examples of both. I'm gonna go down a little bit more. Oh, that's all the space we have to work with. Good stuff. Yeah, without changing the composition, and that is done by changing the composition. So I'm going to give you a few examples of both. The melting point. By melting a substance, heating it up to the point where it changes of form. Melting, by the way, is changing from liquid to, or solid rather, to liquid. I'm gonna cross that out and put in the opposite direction. So solid to a liquid. That's what melting is. It's like melting water. You melting an ice cube. You put it on top of a stove, heat that sucker up, and it goes flying into a liquid before it goes straight into a gas. It doesn't go directly into a gas. It turns into a liquid. You can see it waving around. Yay, yay, yay. Well, you might say, hey, wait a second, aren't we changing the composition? Well, the composition is the chemical formula of a compound. And the chemical formula of water, this is a common one, it's H2O. And by turning the H2O, the ice cube, into the liquid, we're not changing any of its chemical properties. By changing any compound, for that matter, into its different forms, into its different four forms, which are solid, liquid, gas, and plasma, if you recall, we don't really change the composition. So just changing all of those points doesn't matter. Density can be figured out by just weighing the substance that you have, throwing it into a jar, and seeing how much of the jar it takes up. It's just, remember, density is mass over volume. Remember that by DMV. This is a very important equation. You see density of a lot of elements, and you got to know how to work with it. You can by density you can go from volume to mass, which is actually really helpful. So we have density that can also be determined. What else can be determined? Let's see here. I'm throwing this off the top of my head. We can figure out mass, I guess. Yeah, that doesn't change anything. We're not changing the composition. We still retain the same amount of H2O, regardless of whether we weigh it and then throw it into whether we weigh it. I mean, yeah, I guess you weigh it and then throw it into a soda can or whatever, or if we figure out the density of it. Whereas changing the chemical composition, this means we're gonna completely destroy H2O. We're gonna turn H2O back into, well, H2O is made up of hydrogen. We're going to turn it back into hydrogen. We're going to turn it back into oxygen. Completely annihilate it. We're going to say, no, you can't do it anymore. We're going to turn it into hydrogen, and we're going to turn it into oxygen. Don't worry about it. I have those. I'll worry about that later. We're going to completely annihilate them, remember. Burning it. If we burn it, we turn it into a lot of carbon. We turn it, not carbon. We turn, if we burn H2O, if we burn water, I mean, I know that's actually a bad example. If we burn salt, as you'd imagine, burning salt would rip it apart in its components. We're ripping apart the sodium, ripping apart the chlorine, ripping apart both of them, and then we wind up with two separate elements. So we've changed it in a way. So that's a chemical composition. We've changed the composition in order to figure something out. By doing that, we figure out though that it's made up of sodium and chloride, but we've destroyed it. We've destroyed the compound, and it's going to be really hard for us to get it again. Reactability. That's a pretty self-said one. Let's say I take our water, and I dump it on top of, let's see, this is a good one. Dump it on top of cesium. As you'll learn later, if we dump water on top of cesium, or cesium on top of water for that matter, huge explosion. We'll learn that later when we learn about when we learn about stuff like that, we'll learn why. But, if we figure out that, okay, when you have water, do not throw that baby on top of cesium. Let's see, I'm trying to think of what else. Oh, oxygen is highly reactive. And the only way we figure that out is by taking a bunch of oxygen and throwing it on top of different elements, combining with different elements. And the only way we figured that out, figured out the chemical property of oxygen as being highly reactive is because we've destroyed it. We figured out a chemical property by destroying it. So from this we get a general rule of consensus agreed upon by everyone that I'm gonna draw this actually I'm not gonna draw this. I'm gonna write it out. To make a chemical observation, you have to alter the substance. We already learned what a substance is in the last part, and I don't know why it always does that, but every time I type, it always goes 10 miles higher than I want it to. So we have to alter the substance. I'm going to do this in a different color. We have to alter the substance in order to make a chemical observation. Again, in order to figure out that oxygen was highly reactive, we have to react it with, let's say, carbon to create carbon dioxide. Oh, that was ugly. All right, so that was pretty solid. The states of matter. States of matter, as you learned, there were 4 of them, and these states of matter have very special properties. We know a lot about solids. We're gonna cover this actually a lot later. We're gonna cover these in depth. The properties of liquid and gases, not so much solids, because solids have an entire study. People have PhDs in crystallography, which deals with like figuring out the composition, the way that solids look like the chemical level and the atomic level. So we're not going to really worry about that, but we're going to learn about liquids and gases, because these are the 3 most abundant elements in our planet. We actually don't have any plasma, as far as I know, inside our Earth, because we don't have anything remotely close to the amount of temperature required to turn that gas into plasma. So we're gonna learn a lot about these. So I figure since we're gonna learn about gases and liquids later, let's learn a little about solids. Well, solids, if you they still are moving. You'll learn later that atoms are always moving. They always are moving. The atoms that make up solids, like the big chunk of ice, the big cube of water, ice cube, it's still moving, but it's very small, and they keep on bumping into each other, and overall they, an atom might go like, oh yeah, I'm gonna go over a trip, oh, gotta go back, you know what I mean? So it's like solids are weird like that. Let's see, what else is cool about, okay, as you heat up solids, they become a liquid, then they become a gas, and if you take that baby in outer space and expose it to a big, like, a supernova or something, it becomes plasma. And by the way, a big supernova, yeah, that makes no sense whatsoever. Let's see here. Okay, that was weird. That was really weird of me to make that noise. Physical changes. Again, we're gonna go back to that real quickly before I call it a quits. Let's say I have a piece of paper. If I tore it up, would that be a chemical or physical change? It'd be physical, because I still have the compound that makes up paper. I don't know what the compound that makes up paper is, but I believe it has some kind to do with carbon. It's plant, so I guess it has something to do with carbon, nitrogen, oxygen, different amounts. Cutting. If I cut that paper up, would it be a physical or chemical change? It'd be physical, because we still have the chemical. Let's say I burned the paper. Would that be a physical or chemical change to burn it? That would be a chemical change, because we are setting it on fire, so we're destroying the compounds that make up paper. I don't really know what the compounds that make up paper is, so I was going to go off on a tangent, but I guess I can't do that, so you guys win today. Let's do another one. Let's do carrots. Let's say you let's say you cook carrots. You're cooking a carrot. Are you making a physical or a chemical change to make it softer? It becomes it becomes a chemical change, because it's breaking down the sugars. But if you said physical, I understand why you're saying that, because you still have the same carrot at the end. So that was pretty. I mean, I was just looking at my notes and I wrote down carrot for some reason, so I was like, might as well make the most of it. All right, this is not too hard. All the stuff that we're learning, we're just learning about physical versus chemical changes. We're learning about properties of matter. That's really all I have to teach you guys as far as matter is concerned. I know these tutorials are actually kind of beat right now when I'm first starting to learn about matter. I don't know if you like matter or not, but I didn't really like matter. Don't worry though, we do get into some pretty cool chemistry stuff, but that's not until a couple parts in. Actually, after this, we're gonna actually move on to significant figures, the next real topic. Then we have to worry about uncertainty with measurements, accuracy versus precision. And then we do a little bit of something called dimensional analysis. Then we go into the atom and start learning about the atom. So that's pretty cool. So on the next part, we're going to learn about mixtures. And mixtures is my weakest topic as far as chemistry is concerned. So I apologize if I'm kind of incoherent. I'll do my best, though, because I love you guys. Bye.